Okay, let's go into example 3. So example 3 give you a pulley system. What is the first step every time you see pulley system? Datum. Okay. Nico, what is the datum positive direction for B and A? Which one? Which one positive? Which one go up positive? You tell me. I'm asking you datum for A and B. Which one going where is positive? Going up positive. How you know going up is positive? On the diagram. Where tell you go down go up positive? Any arrow showing go up positive? Then where's the arrow showing you? Huh? Then SB? Okay. Again, you surprise me. Why going up positive? Okay, yeah. The datum only have one datum here. Why you mention go up? No.
The last one got one example is datum here, the particle or the point, then going down is negative or going up is positive. The another example.
We are now at pulley system. We are not at potential energy. Potential energy above datum is positive potential energy. Going down is negative potential energy. This is MGH. MGH. Don't confuse potential energy and pulley system. Now I know where you confuse. Pulley system always refer to the diagram. If the diagram tell you arrow only pointing down, just follow the direction. It's like a traffic sign for you. Don't confuse with the potential energy datum. Okay. So after datum, what do you do? Find the total length. Why find total length, Nico? What's the purpose of finding total length? Yeah, you get to find velocity, but why you still want to find velocity? Why you find the total length? What's the end result of finding the total length? You are comparing what? Huh? Okay. So you are comparing velocity between two bodies, right? Okay. So once you have this one, then you are given the weight. One is 3 kilogram, one is 5 kilogram. Object A, 3, object B, 5. It tell you if system is released from rest, you are given initial velocity. Velocity block B is you need to find velocity of block B in after 6 seconds release. Ignore the mass of pulley and cord. Here you ignore the mass of pulley and cord and not ignore the mass of the object. All right. So if you release the object, how these two objects behave? Logically, if you release these two from rest, huh? Huh? Which one go up, which one go down? Okay. So you draw free body diagram. You have two body there. You need two body diagram. What is the free body diagram for A, Nico? How do you draw free body diagram? Free body diagram for A. Okay, your answer is 2SA. I'm asking you to draw free body diagram. Oh no. You need to draw free body diagram, right? Inside free body diagram, what is your focus? You focus on force only. What deal with 2SA? Focus on force. Object A, what are the force you have? Then what else? Tension? How many tension you have? Object B, what do you have? Wait. Draw free body diagram. For first object, I draw circle because this pulley was tied to the A. So no longer, no matter how this short length between A and D, it will still do not change anything. So my free body diagram for A will be my tension cable to go down is TA, and then I have 2 TB. So my A will have WA equal to mg, go down, and go up is 2 TB. But for my B, because my other side of the cord was linked to B, so here I only have 1 TB. Okay, on the A is 2 TB, on B is only have single TB. Okay, makes sense to you? Right. Then again, direction, when you have pulley system, always follow the diagram. If the diagram show you go down positive, means all go down positive. Don't confuse yourself with, hey, this object move up. Why I put this one positive or negative? Don't confuse. Huh? Always follow the diagram. If the diagram positive, go down, then go down positive. Right? So you overlap with the kinetic diagram with the velocity or acceleration. Okay, you put velocity or acceleration inside the diagram. In this case, because we are now in chapter 4, we are dealing with impulse and momentum. We don't need acceleration unless the question asks you to use uh, second Newton law. Then you need to include A inside your free body diagram because second Newton law is F equal to ma. Although chapter 4, principle of linear impulse and momentum derive from F equal to ma. A. BB also same. The question asks you to find velocity of block B after 6 seconds. So, pulley system, you find total length 2SA plus SB. Right? After integration, what do you get, Nico? After time differentiate, what is the next step when you find total length? Integration. So what do you get? 2SA become what? Your answer is 3. 2SA plus SB equal to total length. What do? You do time differentiate, right? What is S? Yeah, then you time differentiate, what do you get? So what is the next answer for this one? 2SA become what? 2 what? 2VA plus BB equal equal what? You integrate total length with time. What do you get? Y0? Huh? Because we cannot integrate, that is your answer. What is the process here? You differentiate with time, right? Why you link integration in your answer? Okay, I repeat one more time. What is your how you get VA from SA? How you get VA? How you get VB? So you differentiate LT total length. What you get? Y0. My answer Y0. There is no such thing you cannot integrate. Mathematics, you say to your mathematics teacher, I cannot do this one. Why you get 0? What mean by dt? Yeah, what mean by differentiate t? What happened to the total length after you differentiate with time? Why you get 0? Why 0? Because total length doesn't change with time. That's why you get 0, right? Okay, you differentiate, then with time, then you move relationship between VA and VB. So you get 2VA equal to minus VB. What does the negative sign means to you? What, huh? Why negative? Huh? Huh? Opposite direction. Huh? Not the acceleration. The acceleration is A. Okay, you integrate one more time, you get A, but we don't want to go there further. Why? Because we are in chapter 4. In chapter 2, yes, you integrate one more time. We call for principal impulse of momentum. What is the equation? mv plus integrate ft equal to mv2. Huh? Without integrate sign, still wrong. So you write block A, mva plus integrate of ft become your impulse equal to momentum. mva1 0 y0 from rest. ft, look at your free body diagram. How many force you have? Two forces, W and 2Tb. So 2Tb T plus WT equal to 3 MB, right? So 3VA. Get the first one. For B, change already because you only have TB and W. So you do the same for B. MV plus integrate of FT equal MB. Substitute the value, you get one more equation. You have two equations. How many unknown you have? What is the total unknown you have? 3. What are the 3? TB, TV, VA, then so you have 3 unknown, TB, VA, VB. Two equation, how you solve? Using Pauli equation. Substitute either one of it, solve. Okay. You get VB and T answer from the simultaneous equation. Okay. We have spent lots of time in explaining the principle of linear momentum, linear impulse and momentum. Now we go into conservation of linear momentum for a system of particles. When I talk about conservation, means something is preserved. Something is preserved. So previously, when we talk about principle of linear momentum, linear impulse and momentum, we have the equation that you see on the screen here. mv plus integration of ft equal to mv. But when the external force, external impulse force, you add all the force together, it balance up. Means all the force you add together, like what you learn in your statics, external force you add up, you balance everything. Means all the force zero. It fall under conservation of definition. Means conservation of linear momentum. You don't need to consider the external force. If the question mentioned consider conservation of linear momentum for a system, it means all the force inside your free body diagram is balanced. Then you don't have impulse. Because you add all the force together, you still get zero. Yeah. So you arrive at momentum on the left equal to momentum on the right. Before equal to after. This is called conservation of linear momentum. Means you only look at momentum only. What's the definition of momentum? mv. So conservation of momentum, you only look at momentum before equal to momentum after. Same with conservation of energy, of conservation of force and energy. So we only look at kinetic energy plus potential energy before equal to kinetic and potential after. Same principle. Okay. So you have two equations for chapter 4. Principle of linear impulse and momentum. That is the first one. Second one is conservation of linear momentum. How you get conservation of linear momentum is because in conservation of linear momentum, all the external force acting on the object equals zero. You sum all the force balance equilibrium, then zero. Okay. Okay. So here is sum of the mass, sum on so all. Okay. So when you talk about rigid body later, how you find you need to focus on, if you have body, then you need to focus on center of gravity. So mvg means focus on the center of the gravity equal to sum of momentum of individual particles there. So m on the left hand side, right hand side, sum of mi will equal to m. Right, you sum all the mass, you still get the m. You can cancel. It means that the velocity at center of gravity will equal to individual velocity. Okay. So we'll look into this one when it come to rigid body. So look at example 4. Individual means inside the system there are lots of particles there. You sum them together. Okay. Example 4. You have two train there, or two boxcar, A and B, both in different direction. So A move in 1.5 meter per second, B move in 0.75 meter per second. When you see two body, then the question asks you if the car collide and coupled together. Collide, coupled means join together. Okay. Determine the speed of both cars just after the coupling and average force between them if coupling takes place in 0.8 seconds. So in this case, what is the conservation of linear momentum equation? What is that? What's the equation just now? Conservation of momentum. M V 1 equal to M2. M2 means what? Means the second object. You only have one object. M1 V2. Okay, so if you have two objects, you have two object or three object lah. Doesn't matter. Okay. The concept of conservation of momentum is momentum, all the momentum before equal to all the momentum after. Right? So let's say you have two particles or two objects. A, B. A, B. So momentum, you focus on individual. So you have MA, VA1 plus MB, VB1. We don't care whether the direction. Okay. So in this case, we will fix one positive direction. To the left is positive. My way of solving, I always follow the big velocity. Okay. Equal to, if these two objects separate, I will have MA VA2 plus MB VB2. This is separate. If it join together, on the left hand side, you join together means what? It move together, right? The mass also join together already. So the equation will become what? MAB, MA plus MAB, V2. Makes sense? Yeah? So you look back to this tutorial question, number 4. We have two boxes, one 1.5, one 0.5. My way of solving it, I will always follow the higher or highest velocity. It means I always need to define my question, where is my positive direction? In this case, 1.5 is higher than 0.5. All my direction to the right will be positive. Which means my VA is positive 1.5. VB will be negative 0.75. Okay, so let's do the free body diagram. So if two coupled means joined together, you have two joined together, you have the two forces acting on the object. Okay, I am object A, or you are the object A. You bang with B. You want to draw the direction of force, right? Same with the spring. Object A, you bang, the B object bang you. What is the direction of force? Go into your body, right? So on the slide here, please don't misinterpret. The chocolate color here link with the negative F arrow and not the positive F. Make sense? Chocolate car banged by B, chocolate A will feel the force is pointing into the body. So the force is pointing into the body of A. That's why you get negative F. Why negative F? We already defined where is the positive. To the right is positive. So you have a negative F. What feel by B? B also same. If you are B, B also feel that the arrow is pointing into object B. So the force is pointing to B, but positive, because all direction to the right is positive. Makes sense to you? Okay. Now, in this case, if you call out the principle of linear impulse and momentum, in the impulse section here, what is the total force you have or total impulse you have? Huh? 0. Huh? Okay, I write m v1 plus integrate f dt equal m v2, right? Makes sense. What is f dt? Impulse, right? What does it mean? This one you focus on all the force that you have in your free body diagram. Here you have integrate minus f dt plus integrate f dt. What do you get? When you get 0, what equation become? Conservation of linear momentum. mv1 equal to mv2. This one focus on one body only. You use it for one body only. That means you focus on individual body when you want to use this equation. So gamma x positive to the right, velocity to the right. This is my assumption. The green color V is my assumption. You can assume to the left positive. No issue. But you will get a lot of negative if it's wrong. If you get lots of negative, means the one you assume in your system is wrong. Okay. So here I did explain why the impulse in the middle is 0 already. So you use conservation of linear momentum. You only focus on momentum. You have two body. On the left, you have two individual body, MVA plus MVB before, but after the event coupled together. So you join the two mass and same velocity, right? So because both A is heavier than A, B is 12 megagram. So no heavy body hit with the light body, of course. After coupled, it will follow the heavy and fast speed body direction. Makes sense. I mean, logically, it's like that one, right? So if not, you can test with the snorkel ball. Go snorkel, and then you hit the body and you see what happens, right? So this is hit and join, right? So you substitute all the value. What you need to pay attention, you need to convert the unit of your mass into unit SI. Okay, 15 megagram is 15,000 kilogram. So what are the unknown you can solve? V2 you solve. And example 4 is a flat surface horizontal cases. It can be switched to the 130-degree cases. So if I slanted the surface, then apply the same. Where is your positive direction? Where is, right? In this case, yeah, something like that. So you focus on the positive direction. You must have the coordinate. Okay, work on example that have angle, right? And then you focus on, if you have angle, you focus on all the momentum in x direction. You solve for that one, and all the momentum in y direction. If you have angle. Okay, you find your V2. And then part B, average force between them if the coupled take place 0.8. average force between them means you don't confuse with the first one. Part B is ask you force between them means you look at one body. If your A, your force is pointing into, so you have negative F, positive direction to the right. So here, you use back the principle of impulse or momentum. Then you have the impulse here. It's a bit different from the S section. S section, you cancel because you look at the big picture. You look at the big picture, it coupled, it cancel. If you not couple, then cannot cancel. Right? So this one, you look at one. So MV1, MV2, you substitute, you get your F average, which is the F value. Okay. Another one, what? B, yes. This is A. B1 also can, but you change all these. The force become positive. Then you change the mass, you change the velocity. Still same. You still get the same answer, 18.8 for B. Okay. One more example, then we call a break. We call it the day. Example 5. You're familiar with this game. You have bumper car A and B go each other. This one again on VA 3 VB. What is my suggestion for the positive direction? By following what? Bigger what? Velocity. Because in this case, bumper A, B have same. If you have same mass but higher velocity, of course you follow the higher velocity. If you have different weight but different velocity, then you just assume one direction based on what you feel is right. Then you mark that one, lock that direction, then you solve. You solve, you get negative sign means what you assume is wrong. I mean the coordinate system is wrong. Means you just flip the direction. Okay, so here they freely collide head on. If no energy loss, I tell you, if no energy loss, it means that it gives you hints. You need to recall chapter 3, conservation of energy, to use in this one. Because the principle of impulse and momentum don't have energy here. So you need to recall what are the equations that link to energy. There's only one. Conservation of energy. What? Conservation of energy, how you write? Kinetic energy. Energy before equal to energy after. You have two types of energy only. So kinetic energy equal to kinetic energy, potential energy before equal to kinetic energy, potential energy after. What is the equation for kinetic energy? Half mg. What is the equation for potential energy? mgh. In this case, where is your datum? Flow. So is there any change of potential energy? No. Okay, but you still need to write potential energy in your equation. Okay, so free body diagram. AB, when they hit together, you freeze the time. Then you put in free body diagram. This is on the surface, so all surface have a contact surface. We have a normal force. Okay, Nico, what is the equation for friction force? Okay. You know that friction force, you have two constant value, right? Mu s and mu k. When you use mu s, static. When the object moving, you use kinetic, right? So again, polish your free body diagram skill. If you don't, you cannot do section A free body diagram, you're going to lose a lot of marks after. Okay, so you put in the force. When you talk about chapter 4, when there's a collision, there is a force acting on the body from the incident. For example, A will have a force pointing to the body of A because of B, right? So how many force you have? Here, it don't give you friction force coefficient, means you don't need to find. Very easy, right? So you see, no friction coefficient means don't need to find friction. So you have how many force? 1, 2, 3. 3 forces for each body. Total you have 6. Conservation of momentum. Why you can use conservation of momentum? Why? You still remember what I write on our whiteboard here? Why we can use conservation of momentum in this case? Why? 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 Yeah, because the forces acting on each body, the F, capital F there, cancel the impulse. No impulse inside the system. Although there's a force, yes, there is an impulse, but they cancel each other, become 0. That's why you can use conservation of momentum. Make sense? Okay. So you try to understand the principle. Why we can use this one? Because the force cancel each other. So you only have momentum before equal to after. In this case, this is not coupled. Once you bang, it break. Once you bang, it break. So you substitute the value. What is VA? Nickel, what is VA? What is VB, Nickel? 1 negative. Okay. So VA, you need to find. VB, you need to find. Okay. So you have 2 unknown. You only have 1 equation. How you solve? Just now I mentioned 1 keyword. No energy loss. You need to recall chapter 3 equation. Conservation of energy. So there's 1 equation here, right? So you need to use conservation of energy. Kinetic plus potential equal before equal to after. What is the equation for kinetic? Okay, mv square and mgh, right? So we have 2 body. Don't forget you have 2 body. Each body will give you kinetic energy. So MAVA square half then plus the B1 equal 0. Why 0? Because there's no change of H in your potential energy. Equal to MVA2 square because it's a separate body. Same with the second one. This one gives you second equation to solve the unknown. You do substitution, you get another equation. All right, you get V square plus VB square plus 13. You have this equation. Substitute back here, cancel the A or B. You get a square root. You get a quadratic equation. Recall how you find the quadratic equation roots. X equal to minus B plus minus B square minus 4ac divided by 2a. Use that one. What is your VB? How many value you have? How many value VB you have? Huh? y2? If you, yeah, you have two roots. Are they same number? Okay, you get two number. You get 3 and minus 2. Which one you use? Y3? Y positive direction? Y negative 2? So the final answer is what? After collision, what is the velocity of B? 3 or minus 2? Y minus 2. Then what happened to 3? What I mean by 3? Okay. This one you need to recall what is your understanding in quadratic equation. When you solve quadratic equation, you have two roots. It means that VB have two answers. Is 3 and minus 2. Means that VB have two answers. One is minus 2, one is 3. You look back in the diagram. Initial velocity B is what? Negative 2. So you already have negative 2. Another answer is 3. The answer is 3. Because this is a quadratic equation. Quadratic equation you have two roots. Means both also correct. But it like returning to the same, what you call, same intersection point. So you have two. Right? So this one will give you like this one. But at the same time, if you freeze the time, you have the two answer here. Right? This is quadratic, right? X squared plus X plus C, for example. So you find the roots, means you have two answer. This is before. This is after. Before already have minus 2. The question asks you what is the velocity here. Get 3. So answer is 3. Understand?
That's why in BB still we get 3
No, you get 0.
that equation.
You substitute minus 2 here, you get 0. You substitute here. You substitute here, you can find your VA. But you substitute 3. You substitute 3 here, you get VA2. If you substitute minus 2, you'll get 3. Makes sense. Okay. So these are the explanation that I explained on whiteboard, and also there's some notation. Right? Okay, we stop here. Next lecture, we look at example 6.